In this video, I would like to do just a couple of example calculations to show you how we can use the equivalent capacitance formulas in order to simplify a problem. Okay, so let's start with the series case. So suppose we have two capacitors that are in series like this, and we know what the capacitances are. So let's say that this one is 100 microfarads, and this one is 200 microfarads. Okay, we want to know what is the equivalent capacitance of these two capacitors together. Well, the formula for equivalent capacitance for capacitors in series is 1 over C equivalent equals 1 over C1 plus 1 over C2. Okay, and in this case, that's going to be 1 over 100 microfarads plus 1 over 200 microfarads, and we need to figure out the equivalent capacitance here. Well, I could plug those into a calculator, and I'll get 0.01, and then sort of weird units, 1 over microfarads, plus 0.005, 1 over microfarads, which I can add together, and I'll get 0.015, 1 over microfarads. Okay, and remember that's 1 over the equivalent capacitance. Okay, so in order to find the equivalent capacitance, I have to take the reciprocal of that. So I get C equivalent equals 67 microfarads. Okay, so it's a bit of a weird calculation, but you'll get used to doing these, I think. And there are a few things that you should notice. So one is by being careful about the units, you actually can prevent yourself from making some common mistakes. So you know that your capacitance needs to come out to microfarads. And so if you get to this point and you think you're done, and you see that the units are 1 over microfarads, then that'll remind you that you haven't gotten the capacitance that you need. Another is that if you compare the two starting capacitances that we have, 100 and 200, we ended up with 67. So the equivalent capacitance was actually less than either of the two capacitors individually. That's going to be the case always for capacitors that are in series. The equivalent capacitance for capacitors in series is less than the individual ones. Okay, but also notice that it's not dramatically less. 67 is still the same order of magnitude as 100 and 200, but it is less than either of them. Okay, now let's do an example where the capacitors are in parallel. Okay, so I'm going to have my two capacitors like this. And let's just use the same numbers. Let's have 100 microfarads here and 100 microfarads here. Okay, well in this case, the formula was C equivalent equals C1 plus C2. Oops, I wanted 100 and 200 just so that it was the same. So in this case, that's going to be just 300 microfarads. Okay, so doing the calculation when they're in parallel is much easier than it is when they're in series. And here we get that the capacitances add together. So for capacitors in parallel, the capacitance is bigger. Okay, so the way to think about this is if you have two capacitors in parallel, then they act like a big capacitor. So these two parallel plates for each capacitor, when we hook two together in this way, are going to look like even bigger plates that are parallel to each other. In the case of capacitors in series, each capacitor interferes with the capacitance of the other one. And so by having the other capacitor in the way, you end up with less capacitance than what you would have had. Okay, so let's do just another example with a slightly more complicated network. Let's say that we have a network that looks like the following. So maybe I have a capacitor like this, and then the wire splits, and I have a capacitor here, and another one here, like so. And just to make things simple, let's say I have 100 microfarads, 100 microfarads. Oops, that was the same one I labeled twice. 100 microfarads, 100 microfarads. Okay, so we want to know the equivalent capacitance of this whole network. Well, the way to do it is to split it up into parts. So I noticed that these two are just in parallel with each other. And so what I can do is I can simplify that into a network that looks like this. I can take 100 microfarads here. And then for that blue network, I'm going to replace it with an equivalent one like this. Okay, so I have to figure out what that capacitance is. Well, if I have two capacitors that are in parallel, I can just add them together. So this is going to be a 200 microfarad equivalent capacitor. And now, when I want to add those together, I notice that these two are in series, and so my ultimate equivalent capacitance is going to be 100 and 200 in series, which I already did, so I know that comes out to 67 microfarads in that case. All right, so if you had a very complicated network, you would just start piece by piece, finding things that are just in parallel or just in series and combine them, and then draw a new network where you have simplified it in that way. We can handle very, very complicated networks by just breaking it down into pieces like that.